Hey everyone, my name is Mika Asaba and I'm a fifth year PhD student at Stanford University. So the main work that I'll be presenting today is in collaboration with Young Woo, Brandon Carrillo, and Hyo Kwon. So as humans, we're really curious about what others can and cannot do. And the question is, how do we figure this out? Well, we sometimes have direct information about what others achieved and how they did so. So we might see their actual performance, so they get an A or an F. We may reason about the difficulty of the task, so whether it was easy or hard, and we may also consider the agent's effort. Did the agent have to put in a lot of effort and take a long time in order to succeed, or did they solve the task really fast? Now, some have proposed that these concepts are embedded in an intuitive theory of competence that allows children to reason about their own and others' abilities. But we may not always have direct access to these cues, to their performance, the task difficulty, or their effort. Now, luckily, these instances are often embedded in rich social contexts in which there's often another useful source of information, which is feedback from other people. So for instance, we often get evaluative verbal feedback from others, like their praise or criticisms. And lots of work has shown that children are sensitive to both the content and the context in which verbal feedback is provided. And what I'll argue today is that children may also be sensitive to others' nonverbal emotional expressions when they're drawing inferences about others' competence. So let me give you an example of what I mean here. So imagine that Zoe is doing a math problem and she gets it right. Her teacher was watching her and shows surprise to Zoe's success. So what would you think here? Even though Zoe got the problem right, you might understand that the teacher didn't expect Zoe to do it correctly, and you might even think that perhaps Zoe isn't so good at math. Now, imagine that you saw another student, Hannah, succeed on the same math problem, and the teacher just shows a neutral happy face in response. So even though both students solved the exact same math problem successfully, you may have the intuition that perhaps Hannah may be better at math compared to Zoe because of how the teacher responded to each of their successes. Now, by contrast, imagine that two students failed at the same math problem, and the teacher shows surprise to Kyle's failure, but not to Alex's. Then we might actually think here that Kyle is better because the teacher's surprise indicates that she expected Kyle to succeed and not to fail. So these are the key intuitions that we tested in our study. And these intuitions stem from much previous work about children's use of emotion as information. That is, children's ability is to draw rich inferences from others' emotional expressions. And collectively, this work has found that children attend to others' emotional reactions and can use them to infer unobserved events in the physical world and the hidden mental states of others. And so the idea here is that this work provides suggestive evidence that these inferential capacities may also allow children to learn about the internal qualities of agents, specifically their competence. And so the key question that I'll ask is, can children use others' emotional expressions, specifically surprise, to infer an individual's relative competence? And then I'll showcase some ongoing work towards the end asking whether these inferences also extend to how children reason about the competence of a social group. And so in this experiment, we first showed participants a teacher and two of her emotional expressions. So here's her baseline expression that we explicitly labeled as not surprised. And the other expression is her surprise one that we explicitly labeled as surprised. And then participants saw the same trials that I showed you in the very beginning. So there were success trials like this, where two agents succeeded at the same task. The teacher shows surprise to one, but not to the other. And then there were fail trials where both agents failed at the same task. And again, the teacher shows surprise to one, but not to the other. Now, after each trial, we told participants that one of these kids is better at math and asked them who is better. So this was a within subjects design where participants saw multiple trials. Half of them were success trials and half of them were failed trials. In each trial, the two agents were gender matched to one another. We also used a variety of activities, including not just solving math problems, but also spelling words and throwing and kicking. Okay, so we first just validated our intuitions with a group of adult participants. So here, participants saw 8 trials, 4 success trials, and 4 failed trials. And consistent with our predictions, we found that in the success trials, adults were more likely to choose the student to whom the teacher expressed no surprise as being better at math. So here, the large circle is the group mean, and the smaller circles are individual means over the 8 trials. So now let's look at the failed trials, and also consistent with our predictions, we see that adults chose the student to whom the teacher expressed surprise. So here adults are choosing different agents as the more competent one, depending on the teacher's emotional response to their performance. So then we recruited a wide age range of children, 4 to 9-year-olds, to see when this ability is developing. Now, as a whole, children showed a similar but weaker pattern of responses. And notably, we found an effective age where children ages 6 and older, but not younger children, the 4 and 5-year-olds, were showing the predicted responses. But as you can see, this was a relatively small sample size over a broad age range. And so we next decided to run a larger scale pre-registered replication. So here we recruited just 6 to 8-year-old children. This was all done over Zoom. We started this experiment right after the pandemic hit. And so what we saw here is actually a replication, again, of the initial findings, where children were more likely to choose the agent to whom the teacher expressed no surprise when both agents succeeded, and the agent to whom the teacher expressed surprise when both agents failed. So what does this mean? So to us, this suggests that adults and children by age 6 can use others' emotional responses to performance outcomes in order to draw inferences about others' competence. Now, if you think about it, this is really not a trivial process at all. Here, children had to attend to the students' performance outcomes, whether they failed or succeeded. They had to also attend to the teacher's emotional expression, so was she surprised or not? And from there, integrate these two cues in order to draw an inference to the student's relative competence. And so in these studies, what we did is that we asked children to infer the competence of individual agents from observing how a teacher responds to their performance. Now, if you think about it, over repeated observations of individuals who come from different social groups, we may form beliefs about the group's abilities, even from relatively minimal covariation information. And so in our ongoing work, we test this possibility and ask whether children can use a teacher's surprise expression to infer a social group's competence. And so rather than present children with real social groups, we use novel minimal groups that look like this. So in this task, children meet a novel kind of creature. We call them gazorps. These gazorps all go to school together. There's a red team of gazorps and a blue team of gazorps. And so then participants are told that the gazorps are playing this game called Space Adventure, and the teacher is watching them. They then see a member of each team attempting the game. So for instance, they see a red gazorp and a blue gazorp who both succeed at the game. And the teacher shows surprise to the red gazorp, but not to the blue gazorp. They then see a different red gazorp and a different blue gazorp both fail, but the teacher's emotional expressions here are switched. So the teacher shows surprise to the blue gazorp's failure, but not to the red gazorp's failure. Then we show participants new members from each team, so a new blue gazorp and a new red gazorp, and we tell them, hey, so here are 2 new gazorps. Only one of them won this game, Space Adventure. Who do you think won the game? And so critically here, both teams succeeded and failed the same amount. They also received a surprised expression and a non-surprised expression from the teacher. But the covariation pattern is different between the two groups and suggests that perhaps the blue Gazorp team is better. And so far in our pilot data, what we see is that the majority of participants are choosing in line with our predictions and report that the blue Gazorp is more likely to have won this game. So this is just our pilot data so far, and we've just pre-registered a larger sample a few weeks ago, and I look forward to sharing those data soon. But broadly, I see this work as a step towards better understanding the inferences that underlie stereotype formation and the role of emotional expressions in that process. So even as we as adults may learn to say the right thing, nonetheless, our subtle emotional expressions, like little expressions of surprise, may reflect our underlying biases. And what this work hopes to address is whether children are sensitive to these cues and use them to learn about other people. And so what I've shown you today is that children by around age 6 can use others' expressions of surprise to infer an individual's competence and potentially generalize to a group's competence from even minimal covariation information. Now, of course, these inferences likely depend on who the emoter is, that is, who is expressing the emotional reaction and what that person knows or believes about the students. So here we use the student's teacher, but if we had instead used someone who had a false understanding of the student's performance or was just ignorant to their performance in general, then that person's surprise should be discounted here. But broadly, taking a step back, this work suggests to us that emotional expressions, even including non-valenced ones like surprise, are a powerful source of information and may guide children's learning about the internal qualities of other people. And broadly moving forward, we hope to combine developmental and computational modeling approaches here. So modeling can be really fruitful in understanding the basic computations by which stereotypes may be formed, even from relatively minimal social feedback from others. And as a first pass, we're currently working on developing models that formalize pragmatic inferences from others' verbal and emotional expressions. And we hope that this approach has the long-term implication of allowing us to capture the underlying computations for our social learning about social groups. And additionally, down the road, I'm really excited to ask about how these inferences affect children's own learning, motivation, and self-concept. So far, we've asked about children's inferences in third-party contexts, and I would love to see how these inferences actually affect children's own motivation and self-evaluations. Okay, thank you so much. That's all I have for today, and I really look forward to all of your questions that you have.